Alright, 3 problems. Now we're not solving square roots, we're solving cube roots. And solve a cube root and a 1/3 power. Let's just remember those are the same thing. Alright. I can solve a radical function that involves roots other than square roots. Alright, by raising both sides to the index of the radical as a power, right? So to solve a cube root, or equivalent, the equations having a power of 1/3, you can cube both sides. And really it's that easy. If I subtract 7, I get the cube root of x plus 2 equals -2, and then I cube both sides. Just like square roots remove squares, cubes remove cube roots. So these guys cancel out. I get x plus 2 equals, well, cube root of -2 is -8. I subtract 2, and I get x equals -10. Let's go ahead and try it. Say we get the cube root of -10 plus 2 plus 7 equals 5, which gives me the cube root of -8 plus 7 equals 5. Cube root of -8 is -2 plus 7 equals 5, and sure enough, 5 equals 5. Done. Alright, so going over here, this is a little tougher, alright, because now I'm going to have to cube this x plus 1. So I got x plus 1 cubed. And instead of doing it like this, I'm just going to write it 3 times, and we'll work this out. So this, of course, is just going to be x minus 5, and we'll start working this out. These two, and again, this is just FOIL. That would give you x squared plus 2x plus 1 times x plus 1. And then I'm going to work this guy out. I'm going to multiply this by both of those, which gives me x cubed plus x squared, 1x squared. I wrote kind of 2x there, but that's x squared. Alright, then we'll multiply this by both of those, which gives me 2x squared plus 2x. I'm going to multiply this by both of those, which gives me another x plus 1. So, minus 5. That gives me x cubed plus 3x squared plus 3x, wow, what do we got, plus 1? And that's equal to x minus 5. Well, let's go ahead and bring everything together. We're going to add 5 plus 5. Subtract x while we're at it, minus x. And 0 equals, what do we got? X cubed plus 3x squared plus 2x. It's like plus 6. Alright. I don't think I've messed up here. No? Alright. Well, we're gonna go ahead and give this a shot. It looks like, well, here's hoping this works out real quick. In fact, I'm going to check something really fast. Okay. It looks like if I do this, I can factor by grouping. Looks like if I bring an x squared out here, I get, what do we got? X plus 3. If I bring out a 2 here, I get x plus 3. And then I've got, what do we get? X squared plus 2. And then x plus 3. And let's keep going here. So we've got to set both these factors equal to 0, so we'll go x squared plus 2 equals 0, and x plus 3 equals 0. If I subtract 2 here, we're going to notice something. This is going to be no real solutions, because I can't get the square root of a -2. Alright. So if I'm looking at this guy, let me pull this up so you can see it again. No real solutions. And this guy's, if I subtract 3, I get x equals -3, which is our only solution. There we go, one more to do. Let's do this guy right here. start by dividing this side over here by 2. Divide by 2. And I've got x minus 50 to the 1/3 power equals, what is that, negative 8. Oh, I'm sorry, negative 5. I wrote the right answer there. And then we got to cube both sides, which gives me x minus 50 is equal to, what do we got, negative 125. If we add 50 to both sides, we get x equals, we got negative 75. And there's our other answer. So, can a cube root have an extraneous solution? That's the question at the bottom. The answer is really no, right? Because when you cube something, it's a little bit different than squaring something. It doesn't create a new solution. Any odd power can't have extraneous solutions. So, if you think about it, while every positive number has 2 square roots, and one of those may not work, right? Every even root, right? There is just one cube root to everything. So no. 1 cube root for every number, and that literally means there can be no extraneous. So we're done with that.